Okay, so for this last one, we're going to focus on this tangent and a chord theorem. And if you look at your strategy sheet, this is going to be strategy number 5. I called it the leg hanging out theorem um, because we know every angle has two sides, two legs to it. And so what if one of the sides of that angle what if one of the legs is hanging out of the circle? In both of these scenarios, one leg is going through the circle and one is hanging out of the circle. So I called it the leg hanging out theorem. And I just was trying to come up with something that maybe would stick so we could have a name to refer to this strategy. But the idea is that it is still half of its intercepted arc, is half of the measure of its intercepted arc. So going from where this intersects the circle all the way around to that vertex, those are the intercepted arcs in between the legs of that angle. And if this is, let's make up some numbers here, if this is 100, then this angle would be 50 degrees all the way out to this other leg hanging outside the circle. If this was like 200, then this would be like 100 degrees for that piece. So it's half of the arc. And that was strategy number 5. So one way to think of it is to keep it straight is that our first strategy, the central angle strategy, her vertex is on the center. It's all about where the vertex is on the center. And then in both strategy 2 and strategy 5, the vertex is on the rim of the circle. And anytime it's on the rim of the circle, then it's half, right? On this one, it's half, and then also in strategy number 5, the vertex is on the rim of the circle, and it's half, okay? So just helping you to try and keep those straight. So here we go. Let's find the value of each variable. You may assume that rays that appear to be tangent are tangent. So let's first of all look at our angle A. It goes from here to here. So those are the two sides of angle A. The arc in between those angle legs would be this arc that goes all the way from there to there, and that is the 256. So we know that because the vertex of this angle is on the rim of the circle, that's how we know that strategy number 5, the leg hanging out theorem, does apply. And you're going to do 256 divided by 2. Half of that would be 128 degrees for A. Okay, B is a little bit more exciting. You still have the angle A hanging out here. This time there's two pieces of information we don't know. This is our intercepted arc B, and we don't know B nor do we know A. And so that makes things a little bit trickier. So one strategy is to use 360 degrees for the whole circle minus the 224 to get 136 as the other part of the circle. So that would be our B. And then you could take half of that to get A. The angle A would come out to be 68 degrees. The other strategy is maybe you want to take half of 224 to get this angle to be 112 from here to here, and then maybe you want to use a linear pair to find that to be 68. Ultimately, it doesn't matter. There's different strategies. As long as you get the 68, we're good. So the last thing we have here is a you try. And so pause the video, give that your best shot, and then we'll see how that goes. Okay, so on this one, I used the fact that there's 360 degrees in the circle. I subtracted out the yellow arc that we knew, the 144, and that left me with the remaining part of the circle, the 216 for B. Then for A, I took half of that, so I took 216 and divided it by 2 to get 108. So not the only way to work that. Again, you could have found this angle by taking half of 144 and then used the linear pair to find 108 and then doubled it. Either way, all that works. All right, so let's look at this last one. Actually, I think I'm going to do this in the next video.